So yesterday we were working on the under relaxation expression, and we have seen that in under relaxation, the idea is to not take the whole updated value of phi. So if I solve normally, phi p new value will be calculated as minus summation of a neighbors times phi neighbors plus bp over ap. However, since I want to under relax, I will not take the full new value. I can say instead, I can do the following. The new value can be written as the old value plus the difference between new and old. يعني if you don't under relax, إذا بتاخدوا الvalue as it is, okay, then lambda will be equal to 1. يعني إذا أنا هون بزيد plus phi old اللي هن مسمينها phi star, okay, minus phi old, I don't change anything. If I just add and subtract the old value to phi new, so this is the new value, I don't change anything. The idea is if I want to do under relaxation, instead of taking the new value as it is, I will take the old value plus a percentage of the difference between old and new value. So the idea will be, instead of saying I multiply this term by 1, I should multiply it then by a value lambda smaller than 1. If I want to do under relaxation, I use lambda smaller than 1. If I want to do over relaxation, I should use lambda larger than 1. Okay, so this is the idea. If I take phi p as it is, lambda is 1. If I take under relaxation, I can define phi p as phi old plus lambda, which is a fraction, times phi new minus phi old. And if I want to do over relaxation, I use lambda larger than 1. So this is the idea. Now, how the coefficients will be modified in my equation? To know how the coefficients will be modified, I will use this formula. Okay, this is the formula I have. I will do the expansion to find what are the new coefficients of my terms. To do this expansion, first I will multiply. If you want, I will have all terms here should be along same fraction. And I will multiply all terms by AP over lambda. Okay, تتروح هيدي هون lambda over AP تبع this term تتروح. So if I multiply all terms of my equation by AP over lambda, what do I get? I get AP over lambda times phi new equals to AP over lambda times phi old. Now here, when you multiply by this term by AP over lambda, this term who also multiplied by lambda over AP. When you multiply it by AP over lambda, بتروح lambda over AP بيبقى بس this term, and minus for this term phi old can multiplied by lambda. Okay, now you are multiplying by AP over lambda, يعني بيصير عندي minus phi p old times A. Okay, so now if I rewrite my equation, صار عندي AP over lambda times phi p equals to AP over lambda times phi old. بس تكون old بنحط لها star. يعني this symbol star means the old value of phi p. Plus هلا قلنا هيدا الترم لأنه ضربنا ب AP over lambda وهو already كان times lambda over AP صار الكوفيشنت تبعه 1. So it's minus summation of A neighbors times phi neighbors plus BP. And finally, we have phi P old multiplied by AP. So minus phi P old multiplied by AP. Now, what is my purpose? I want to write the equation in the following form. Okay? A certain coefficient multiplying phi P plus sum of A and B times phi neighbors equals to a certain constant term. So let me take then this term to the other side. لأنه هيدا الترم هو function of phi neighbors. I will take it to the other side. And all constants, I will keep them to the right side. The constant values هن AP over lambda times phi P star اللي هي old value. I have also BP and I have minus phi star PAP. So now if I just take this term to the other side, I get AP over lambda times phi P plus summation of A neighbors phi neighbors equals to, for the second term it's BP plus, now you can take phi star into factors, the old value, so plus phi star P times AP over lambda minus AP. You can do here a common denominator here. You should multiply then by lambda. So it's AP minus lambda AP over lambda. And if you take AP into factor, بتصير AP times 1 minus lambda over lambda. So if we observe our new equation, okay, you have new coefficients. To do under relaxation, you should update your coefficients. Let us observe together what is the difference. Before, if you don't do under relaxation, if lambda is 1, the coefficient of phi P is AP. However, when you do under relaxation, the coefficient of phi P is AP over lambda. Now, for phi neighbors, it's the same expression. So plus coefficients A neighbors, phi neighbors, this term is not affected, equals to the constant term will be affected. And instead of BP, you have now BP plus phi old times AP minus lambda AP over lambda. This means that when you want to do under relaxation, you should alter the coefficients of phi P. Instead of AP, you should use AP over lambda. And instead of BP, you should use BP plus 1 minus lambda AP over lambda phi old. Okay? So this is the strategy. And when you do iterations, each time you find a value of phi, you can store it in phi old. And then when you want to compute again phi P, okay, you will use the following coefficients to update. When we do numerical examples, you will understand how we do this. This procedure, you know that in any calculation you do iterations. So this is a numerical procedure. You cannot solve from one step because initially you do initial guess. You compute. You say, let me assume phi in all domain equal to a certain value. Then you should solve numerically. Solve a first time. Okay. When you solve a first time, it's not directly the result. So you will update phi. Each time you update phi, okay, you will have a new iteration. You will repeat your iterations until convergence. And then each time I update phi, I can say that I have now new value and old value. To calculate, to do another iteration, I should pay attention to alter my coefficients in order to perform under relaxation. Now, how to solve the algebraic system of equations in TDMA? This is the three-diagonal matrix algorithm. So you have several ways to solve for a system of equations. One of the methods is to use numerical techniques you have learned in other courses. So you can use Gauss-Seidel method, you can use LU factorization, etc. The NCFD will develop a numerical technique that will use iterations to solve for our equations. This method is called the TDMA. Okay, what is the idea of the TDMA? The TDMA will solve the equation we developed together using iterations, numerical techniques with iterations. So let us consider now how to use the TDMA in one-dimensional grid arrangement. Now, we can also use it if you have 2D grid, and we will see how. So first, if I'm talking about 1D grid, and I have several points in my domain, okay? You know that for each cell, you need a center. So you need points at centers of your cells. And also you need points at boundaries. And the extreme cells are particular, as we have seen last time, because we need boundary conditions at the extreme cells to be able to solve for variation of the variable within the domain. So the idea will be for each control volume, we have developed together an equation. The general equation is of the following form. We have a certain coefficient AI times phi I. So for any cell, for a certain cell of index I can relate the variable in this control volume to the value of the variable for the control volume just before it, and the value of the variable for the control volume just after it. So here you have I plus 1. And here you have I minus 1. And we have derived together the expression based on the control volume analysis. So we get AI phi I plus a certain coefficient BI phi I plus 1 plus a certain coefficient CI phi I minus 1 equals to a certain source term DI. And this is for any cell if you want within your system. If you have two particular cells at the boundaries. At boundaries, you don't have I minus 1. You don't have a cell for the first cell, you don't have one before it. And for the last cell, you don't have one after it. This is why we start by writing that for cell 1, I don't have phi I minus 1. This means that C1 is 0. Okay? And for the last cell, I don't have anything after it. So I don't have phi I plus 1. So the coefficient of phi I plus 1 then will be 0. So C1 and Bn are 0 because I am at the extreme cells. While for the other nodes, for the other point control volumes, I have AI, I have BI, and I have CI. Now, let me start with the boundary cell. If I start by cell 1, okay, I can say that in cell 1, I have A1 phi 1 equals to, so let me replace here if you want, I1 phi 1 plus B1 phi 2. And as we said, C1 is 0 because we don't have a cell before it. So this term will cancel out. Equals to D1. So for the first cell, if I want to relate phi 1 to phi 2, for the first cell, if I take this term the other side and I divide by A1, I get that phi 1 is minus B1 over A1 phi 2 plus D1 over A1. So I can relate the variable at boundary 1 to the variable at 2. So imagine that I gave you phi at 1. If I gave you what is phi at 1 as boundary condition, then all you have to do, you replace phi 1 here by its value, and you deduce the value of phi 2. I can give you other types of boundary conditions. So if I give you the flux, for example, as we did last time, you write the equation, and from the knowing your flux, you can determine what is the value of phi 2. Okay, so always boundary cells can be used to determine. So I can start from boundary cells because if I know a condition here, I can solve for the variable in this node. Then I will move from one node to the other to solve for my different variables. Okay. Now, if I consider any other cell, if you want, for any other cell, I don't have a boundary condition. I have to apply this formula. I have AI phi I plus BI phi I plus 1 plus CI phi I minus 1 equals 2 DI. But I will take the advantage that I already started to solve from the first cell. From the first cell, I was able to express phi I function of phi 2. So now, if I move to cell for my second cell, so for I equal to 2, I is the number of cell if you want. For I equal to 2, if I apply this formula, I get A2 phi 2. So now for cell 2, I have A2 phi 2 plus B2 phi 3 plus C2 phi 1 equals to D2. And since I have already determined an expression of, if you want, a relation between phi 1 and phi 2, okay, from this equation, I already found what is phi 1 a function of phi 2. This is why I can plug in, I can replace phi 1 in this equation by its expression. I can replace phi 1 by minus B1 over A1 phi 2 plus D1 over A1. If I do this, then instead of having phi 2 function of phi 3 and phi 1, I will just have phi 2 function of phi 3. So this is the strategy. I start from the boundary and I reduce then the variables because by starting from the first cell, I can express phi 1 function of phi 2. Then moving to the second cell, by replacing the expression of phi 1 by its value, I can express phi 2 function of phi 2. Let us do it here for this step. All you have to do is to say, I started from this relation. I will take B2 phi 3 and C2 phi 1 to the other side. So I can write that A2 phi 2 is equal to minus B2 phi 3 minus C2 phi 1 plus D2. And if I want to get what is phi 2, I will divide all terms by A2. And now I will replace phi 1 here in this expression. I will replace phi 1 by minus B1 over A1 phi 2 plus D1 over A1. So I will get the following. I will get that phi 2 is minus B2 over A2 times phi 3. Let me clear everything here. Okay, so it's minus B2 over A2 phi 3 minus C2 times. Instead of phi 1, I will write this. So minus C2, but here you have minus, so plus C2 B1 over A1 over A2 times phi 2. And you have, don't forget the minus here, and you have here plus, so minus C2 D1 over A1 A2. Okay, and plus D2 over A2. This is the expression of phi 2. Now, you have this term here, function of phi 2. So I will take it to the other side. I will take it to the side of phi 2. Okay. And now what do I obtain? I have phi 2 times 1 minus C2B1 over A1 A2 equals to phi 3. If you do here common denominator, okay, you get a plus D2A1 plus D2A1 minus C2D1 over A1 A2. Now you still have one step to find phi 2 function of the other terms. Here, this term, you can write it as A1 A2 minus C2 B1 over A1 A2. So to obtain the expression of phi 2 function of the other parameters, you can multiply all your terms by A1 A2 over A1 A2 minus C2 B1. Okay, so now if I do this, I get from the other side for phi 3, the coefficient here, just we forgot to put the coefficient of phi 3, minus B2 over 8. Okay. So now let me multiply all my terms by A1, A2 over A1, A2 minus C2, B1. I get the following. I get phi 2 equals 2. For this term, when you multiply it by A1, A2, you will get A1, A2 times, of course, don't forget the minus. So minus A1, A2, B2 over A2 times this factor اللي هو A1, A2 minus C2, B1. This is the coefficient multiplying by 3. And you can do some simplification لأنه عندنا A2 and A2. So as you can see, the coefficient of phi 3 will be minus A1, B2 over A1, A2 minus C2, B1 plus this term, if you multiply it by A1, A2, then this will cancel out. And then you divide it by A1, A2 minus C2, B1. Okay, you will get this term, which is D2A1 minus C2, D1 over A1, A2 minus C2, B1. And whole A1, A2 will cancel out. So this is just replacement. You are just replacing, if you want, phi 1 by its expression to get phi 2 as function of phi 3. What is the idea we can deduce? We can deduce that as we move from one cell to the other, we are able to express phi at a certain cell, function of phi of the cell just after it. So we can extrapolate this analysis to any cell I. If I do, I can say for any cell I can find that phi I is a certain coefficient pi times phi I plus 1 plus a certain constant coefficient qi. And if I want to get a general expression of phi I plus 1 function of phi I plus 2, I can say for any cell I will do the following. First, I will express phi I minus 1 function of phi I. And then for the next cell, okay, so when I apply now on a cell, so this expression is for which cell? This is for cell I. Okay. Now if I move to cell I plus 1, in this cell I can write the following. I can write that AI phi I plus BI phi I plus 1 plus CI phi I minus 1 equals to DI. So let me now replace in this expression phi I minus 1 by its value function of phi I. This is exactly what we did together in the previous step. So we can deduce then that we can come up with an expression of phi I function of phi I plus 1. And our coefficients, this coefficient will represent pi. And we can find pi function of pi minus 1 and the coefficients ai, bi, ci. And this is qi. Qi is function of di, ci, ai, and qi minus 1 and pi minus 1. So what we can conclude is that once we do it in one cell, you can work from cell to cell and deduce your coefficients for each equation instead of having phi I plus 1 function of the variable before and after. This algorithm will allow you to express at each cell the variable function of the variable just after it. And the coefficients pi and qi are defined from replacement using these two equations. Okay, so as you can see, we started by cell 1. For cell 1, we demonstrated together that P1 is minus B1 over A1 and Q1 is D1 over A1. How? Go back to your first expression here. We said that by derivation, we found this equation. In this equation, this represents coefficient P1, and this represents coefficient Q1. Okay? And as you move with cells, for each cell, you can say that I can express phi I as a certain coefficient Pi times phi I plus 1 plus a certain coefficient Qi. But now together we derived a relation relating Pi Qi to Pi minus 1 Qi minus 1. And now if I know P1 and Q1, I can deduce P2 and Q2. And from P2 and Q2, I can deduce P3 and Q3, etc. So these are the general equations used. Pi function of Pi minus 1, Qi function of Qi minus 1, Pi minus 1. So starting from the first cell, I can move to other cells and find the coefficients to write my system. When we do numerical application, you will see that this is an easy, very simple method. You will end up with a system that is easy to solve. Okay.
دكتور أنا هول الكوفيشنت A و B و C بيكون معي هن؟
إيه أكيد. أنت ال A, B, C, D هول بتجيبهم من الكنترول فوليوم أناليسيس اللي عملناهم سوا. يعني مثل هون. You remember نحن أخذنا case more complex. نحن أخذنا 2D. إذا عندي 2D مش نحن جبنا coefficients إذا بتتذكروا A east, A west, A north, A south. هلا إذا عندك 2D application ما ببطل في north و south، بضل في بس east و west. أوكي؟
نعم.
هلا حتى TDMA you know إنه TDMA كمان فيها تطبق على 2D، بس شو بتكون استراتيجي؟ بنقول let us move in a row. If we move in this line هيك، ساعتها إذا بنطبق TDMA مثل ما شفناها أنا وياكم، بنعتبر إنه اللي عم يجي من النورث ومن الساوث نعتبره كسورس تيرم. هلا بتقولوا لي it's not accurate. مزبوط it's not accurate إذا بعمل iteration واحدة، بس هن شو بيصيروا يعملوا؟ بيصيروا يعتبروا إنه هول الفلكسز بدل ما أعتبرهم function of variables بفوتهم كconstant بستورس تيرم. يعني I use for example إذا أنا عندي initial gas temperature at north و temperature at south and I'm computing the fluxes going through هيدا الكنترول فوليوم، بعتبر إنه حاستعمل الinitial gas أو old values تجيب flux coming inside my cell okay. وساعتها بعمل TDMA أول شيء، يعني هيدي solving method على الرو. ساعتها I update كل temperature بهيدي اللاين TW TP TE، وبرجع بعمل TDMA مرة تانية بس بالvertical direction، وبضل عيد الiteration. يعني بمشي بالTDMA line by line column by column. ساعتها if I do several iterations بيصيروا الابديتس ياخدوا من بعض لحديت ما اوصل للconvergence. اوكي
دكتور هول الفاي 1 فاي 2 فاي 3
نعم
أنا عم بيطلع عندي 2 equations و 3 unknowns. في مثلا شي فاي بقدر
في
أعرفهم
الباوندري.
ورا
ما تنسى انه في boundary condition. boundary condition تعطيك additional information تقدر تسكر السيستم of equations. اوكي هلا when we do problems حنعمل I know انه هي كconcept شوي صعبين. We'll do new problems on this okay so that you can see how these methods are applicable. okay هلا انا TDMA حنستعملها انه يكون اول شيء على 1D، بس انتم لازم تعرفوا انه كمان we can use it in 2D مثل ما قلت لكم. يعني بنصير نمشي TDMA line by line، نرجع بنمشي column by column. ساعتها when we update مرة على مرة by iterating الvalues بيصيروا update. هلا فينا نحن نعمل examples على small number of cells، ساعتها تصيروا تعرفوا كيف بنطبق هول الالجوريثمز. اوكي
اوكي دكتور.
Okay. Now, until now, we have developed a technique called finite volume technique, which was based on taking a control volume, doing conservation analysis, and finding a numerical equation relating the variable at different center of cells. Another method to solve for, if you want, for using numerical techniques is the finite difference method. The finite difference method is based on the Taylor series expansion, as we have seen in the previous chapter, if you remember. So if you want to consider the same case of, let's say, the heat equation in one-dimensional problem, then the equation will be reduced to the differential equation, will be reduced to the diffusion term and the source term. So diffusion term plus source term equal to 0. We are dealing with steady application, no transient term. If you want to solve using the finite difference method, we will compute the second derivative of t with respect to x using Taylor series expansion that we developed together in last chapter. So all we have to do then is to say, let us consider a uniform grid. يعني delta xp equals to delta xw equal to delta x east. That is the distance between centers here, okay, will be equal to delta xt. And this will simplify a little bit the expressions, okay? Now, once we do this, we can use the Taylor expansion around point P to get what is the temperature at east and what is the temperature at west of P. So let us start with TE. You know that the Taylor series expansion has the following form. Between P and E, you have a distance of delta x east, okay, which is equal here to delta x because we are considering uniform grid. So if we apply Taylor series around P, we get TE equals to TP plus delta xe times dt by dx plus delta x square over 2 times second derivative of t with respect to x plus an error of order x cubed.